Black holes are by far the most scary objects in space. Everything that goes inside will never come out again. Now imagine the complete opposite. This is what we call a white hole. Everything a black hole sucks in, this thing spits out. But are they real? If so, can we even travel to other universes through white holes? Or was the Big Bang itself one giant white hole and our universe is inside it? All this is no science fiction, but more later, but I tell you what you're about to discover will completely change the way you think about the universe. So, if a black hole is born from the death of a massive star, then how do white holes form? To understand this, we need to know how black holes are working. When a star many times heavier than our sun collapses under its own gravity, the core implodes, creating a region so dense, so powerful that nothing, not even light, can escape. At the edge of this region lies the event horizon, the ultimate point of no return. Once you cross it, there's no going back. At the center sits the singularity, a place where our current laws of physics break down completely. If a black hole is the ultimate cosmic vacuum cleaner, a white hole is the universe's ultimate cosmic geyser. White holes were first predicted as a mathematical twin of black holes. When physicists looked at Einstein's equations of general relativity, they realized, if you flip the timeline of a black hole, you get something that behaves exactly like a white hole. But here's the kicker. Unlike black holes, we've never seen a white hole. Not even once. If white holes exist, where are they hiding? That's the great cosmic mystery. One of the most exciting ideas in modern cosmology is that the Big Bang itself may have been a white hole. Think about it. The Big Bang was a moment when everything, all matter, all energy, all space-time, erupted outward from a single point. Nothing could enter that singularity, but everything came out. That sounds eerily similar to how a white hole is described. The theory suggests that in another universe, a gigantic black hole swallowed more and more matter and energy, packing it into an extreme state. Eventually, the density and pressure became so enormous that instead of collapsing endlessly, all that energy burst outward, not back into the same universe, but into a new one. In this framework, our universe could be just one link in a chain. Black holes in our cosmos might constantly create new universes on the other side. Those baby universes could have different physical constants, different particles, or even entirely different laws of physics. Some may be unstable and collapse quickly. Others could expand and grow into fully developed universes, just like ours did. This would mean that white holes are everywhere, not inside our universe, but at the start of countless other universes. Our own Big Bang might itself have been the white hole born from a black hole in a parent universe. If that's true, then black holes are not just destructive objects. They could be the engines of cosmic creation. But it goes even further. Some physicists suggest that the black holes we see scattered across our universe could also be gateways to other universes. From our perspective, black holes are places where matter disappears forever. But from the other side, they might appear as white holes, spewing out all that matter and energy into a new cosmos. And here's the twist. If those universes exist, they might play by completely different rules. The fundamental constants, things like gravity, the speed of light, or even the types of particles that exist, could all be different. Entire universes where white holes dominate instead of black holes might be possible. If white holes sound too good to be true, that's because there are big problems with the theory. First, stability. Black holes are stable because their gravity keeps everything trapped. White holes, on the other hand, would constantly be spewing out matter. That should make them collapse almost instantly. In Einstein's equations, a white hole can exist as the mathematical reverse of a black hole. But to keep it open and stop it from collapsing instantly, space-time would need to curve upward instead of downward. That requires something we have never observed in nature: negative mass. Negative mass would push instead of pull. It would resist gravity rather than attract. And without such exotic matter, a white hole would collapse as soon as it formed. This is one of the biggest reasons why physicists doubt that real white holes exist inside our universe. However, the idea becomes more interesting when we bring wormholes into the picture. A wormhole, also called an Einstein-Rosen bridge, is a theoretical tunnel through spacetime. One end of the tunnel could look like a black hole where everything falls in. The other end could appear as a white hole where all that matter and energy is expelled. This is why we can write them into equations, but we haven't seen one in the sky. So where does this leave us? Right now, white holes remain purely theoretical, but history teaches us something important. Black holes were once considered pure fantasy too. Even Einstein himself doubted they could exist in reality. And yet, here we are, taking photographs of their shadows. Could white holes follow the same path? It may take new telescopes, new physics, or even entirely new ways of looking at the universe before we know for sure. Thanks for watching. If you enjoyed this deep dive into white holes, check out our video on the Big Bang and the origins of time itself. See you.